Hey everybody, here's a quick Unit 2 quadratic review. If you see a 2 in the exponent, you have a quadratic. Standard form, ax squared plus bx plus c is going to give you your function when it's set equal to f of x, where we get all the solutions in this nice pretty curve called a parabola. Your x-intercepts, where it crosses the x-axis, are your zeros, your roots, and your solutions. Sometimes our quadratics have two solutions, sometimes one, sometimes none. Sometimes our quadratics are positive, up like a cup. Sometimes they are negative, down like a frown. The parabola has a vertex, and that vertex is the minimum of a positive parabola and a maximum of a negative parabola. If you want to find the coordinates of the vertex using your standard form, coefficients a and b and c, you're going to take negative b over 2a, and that'll be your x value of your vertex and the equation of your line of symmetry, where the graph perfectly folds into half. The output of inserting negative b over 2a, this value, into your quadratic is going to give you the y-coordinate of your vertex. When we go to solve quadratics, we have a couple different ways. We can graph them, use Desmos, find the x-intercepts, and those are our solutions. It doesn't work every time, though, because if it's an irrational number or one of these that never crosses the x-axis, we can't find our values. We can factor the equation. We can set it equal to 0 and use the zero product property to solve a quadratic. Now, when we factor, we've got a couple of different methods that we need to consider. First of all, it helps us to look at how many terms does it have. 2 terms, 3 terms, 4 terms. Don't forget to always take out that GCF first. If it has 2 terms, maybe it's the difference of 2 perfect squares. If it's the sum of squares, it's prime, and you won't be able to factor it. If it's the sum or difference of cubes, you're going to have to follow this pattern. Now, our difference of 2 perfect squares is always going to factor into a sum difference pattern. So here we have an example. We're going to create our 2 binomials and find the sum and the difference and the square root of each term. If we have the sum or difference of 2 perfect cubes, it helps to figure out what your a and your b values are. Now, in this example, my a and b values are going to have to be the cube root of each of my terms. Remember, it's the sum or difference of perfect cubes, so finding that cube root is easy. When we put it into the pattern, we have our a term, our b term, and then a squared, a times b, and b squared. If we're solving this as an equation, we can set this equal to 0 to solve for x, but then our trinomial is always going to be prime. And we'll talk about what to do with those prime examples in a minute. If it has 3 terms, there's a chance you can factor it. Draw a number puzzle or a T-chart and see if you can figure out how to break that quadratic down. When we talk about the T-chart, we're talking about the factors that end up filling in each of these binomials to make this pattern true. We can always check it by foiling. Our x squared splits into x and x. Our negative 6 is the product of positive 3 and negative 2, and 3x and negative 2x add to positive 1x. Sometimes our a value, our coefficient, is greater than 1. We can guess and check. Maybe you're a good guesser, maybe you can spin the numbers in your head and do a good job. Maybe you might want to do grouping. Because if we can replace this middle term with 2 terms, then we can treat it like a factoring by grouping. We can group, look for common factors that can come out, and then that can break down into our 2 linear binomial factors. All right, after we factor, we set each factor equal to 0, and then solve for x. Maybe you want to try to solve by square roots. Now, when we solve by square roots, something easy like this, we take the square root of each side. Don't forget your plus or minus. Sometimes it's a little bit more complicated, and we have an expression that's our perfect square. That's okay. All you have to do is isolate your expression, take the square root of each side, and remember, if you draw the square root, you have to remember your plus or minus. Once you take the square root of each side, you still need to solve for x. If you end up with an irrational value, that's okay. You can just write it as two solutions. X is equal to 1 plus the square root of 10 and 1 minus the square root of 10. Completing the square is our next strategy, and that builds upon this square root idea. Completing the square says, wouldn't it be great if I had this binomial perfect square where I could take the square root of each side? So what I do is I get it. This 21 doesn't fit my pattern, so I subtract it from each side, and I figure out what number does. I take this b value, and I divide it by 2, and then I square it. Half of 10 is 5, so if I had an x plus 5 squared, I would have x squared plus 10x plus 25. Now I can't just go adding 25 anytime I want. I have to honor this equal sign. So this 25 is added to both sides. When I simplify, I get 4, and then I take the square root of each side. Don't forget your plus or minus. Subtract 5, and then you get your final answers. Now the quadratic formula is going to be that Mac Daddy that works every single time. When you want to solve a quadratic equation, you can come up with the answers. If I have 3x squared minus 7x plus 2, and I'm looking for my x values, I set it equal to 0. I have my a value, my b value, and my c value. My x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, I got to tell you the truth. Whenever I figure out my discriminant, I'm going to go ahead and use my calculator. So 49 minus 4 times 3 times 2 is going to be 25. My x is equal to 7 plus or minus the square root of 25 all over 6. This is a perfect square, which means I can keep going. X is equal to 7 plus or minus 5 over 6. So you ready? X is equal to 7 plus 5 over 6. X is equal to 7 minus 5 over 6. My two answers for x, 12 over 6 and 2 over 2. I lost my 6. 7 minus 5 over 6 to 6. There we go. So our final answers here are x is equal to positive 2 and 1/3. Hey, I hope this helped. Good luck on your midterm.